কিনে দেখা শান্তিনিকেতন নাম দিয়েছি। শান্তিনিকেতনে আমি ঘুরতে যাইনি, গিয়েছিলাম একগুচ্ছ স্বপ্ন নিয়ে। আমি 2002 সালে মাধ্যমিক পাশ করি আর 2005 সালে উচ্চ মাধ্যমিক পাশ করি। মাধ্যমিকে আমি সব বিষয়ে ভালো ফল করেছিলাম, কিন্তু উচ্চ মাধ্যমিকে আমি তেমন ভালো ফল করতে পারিনি। তবে উচ্চ মাধ্যমিকে আমি বাংলায় 88 অর্থাৎ 88 পেয়েছিলাম। তারপর হঠাৎই সুযোগ পেয়ে গেলাম শান্তিনিকেতনের সাংস্কৃতিক ভবনে। নামটা সাংস্কৃতিক ভবন হলেও সেখানে আমাদের আবৃত্তির পাশাপাশি বাংলাও পড়ানো হতো। আমি মূলত ওখানে আবৃত্তির চর্চা করতে গিয়েছিলাম। আমি যত সহজ ভেবেছিলাম ওখানে পঠন পাঠন করতে গিয়ে দেখলাম তো অতটাও সহজ নয়। আমি ওখানে 8 বছর পড়াশোনার জন্য ভর্তি হয়ে গেলাম। আমি 8 বছরে যেমন প্রচুর আবৃত্তি বাংলার বিভিন্ন শিক্ষা গ্রহণ করেছি, ঠিক তেমনই পাশাপাশি বিভিন্ন ধরনের আচার ব্যবহারও শিখেছি। আমি 2005 সালের মে মাসে উচ্চ মাধ্যমিক পাশ করে 2006 সালের ফেব্রুয়ারি মাসেই শান্তিনিকেতনের সাংস্কৃতিক ভবনে ভর্তি হই। তারপর থেকে টানা 8 বছর ওখানে থেকেই পঠন পাঠন করি। আমার সঙ্গে আমার মাও থাকতো ওখানে, বাবা মাঝে মাঝে যাতায়াত করতেন। সাংস্কৃতিক ভবনে আমরা মোট 42 জন একসঙ্গে শিক্ষা গ্রহণ করতাম। তার মধ্যে আমাকে নিয়ে 23 জন মেয়ে ছিল আর বাকি সবই ছেলে। আমার কিন্তু বান্ধবীর থেকে বন্ধুর সংখ্যা বেশি ছিল, কারণ বান্ধবীর মনে হিংসা থাকলেও বন্ধুদের মনে কোনো হিংসা ছিল না। পড়াশোনার চাপ থাকলেও আমরা তার ফাঁকেও মজা করে কাটাতাম। বেশি মজা হতো দোলের সময় বিভিন্ন রঙের আবিরে আমরা একে অপরকে রাঙিয়ে দিতাম, আর সাথে থাকতো অনেক খাওয়া দাওয়া। দিনটা শুরু হতো প্রভাত ফেরির মধ্যে দিয়ে। প্রভাত ফেরিতে বিশ্বকবির বিভিন্ন ধরনের নাচ গান আবৃত্তি হতো। প্রভাত ফেরি সেজে উঠত বিভিন্ন ধরনের সাজে পলাশ ফুলের ছোঁয়ায়। বাকিটা পরে লিখব।
The Goldilocks Enigma, Paul Davies. We stay with the difficult idea of the curvature of space in the hands of theoretical physicist Paul Davies. He is one of the most prolific writers of science for a general reader, and there are few among the deep problems of physics and cosmology that he has not touched upon. This extract is from a recent book, The Goldilocks Enigma in Britain, but the cosmic jackpot in America. At the risk of becoming a bore with this buzzing bee in my bonnet, shouldn't we actually start boycotting publishers who confuse everybody with this kind of gratuitous renaming of books as they cross the Atlantic? The Goldilocks Enigma is a lovely title derived from the fact that the bed chair and potties that Goldilocks enjoyed were all just right. This extract is Paul Davies' description of curved space and of Einstein's idea that the universe itself is a hypersphere which is far finite but unbounded, such that no one galaxy is closer to the edge than any other, for there is no edge in any more than our spherical Earth has an edge. WMAP stands for Wilkinson Microwave and Anisotropy Probe, which is a satellite sent up to map the cosmic background radiation left over from the Big Bang. As Davies explains, results from WMAP indicate that Einstein may have been wrong about the shape of the universe, though not about general relativity itself. Warped space. So far, I have been concentrating on astronomical discoveries, but cosmology would not be a true science if it lacked a framework of physical theory within which these discoveries can be understood. The theoretical basis of modern cosmology was established almost a century ago by Einstein in the form of his general theory of relativity. The theory was published in 1915 in the dark days of the First World War, but this did not stop astronomers and physicists from both sides of the conflict taking a keen interest in what it had to say about cosmology. The general theory of relativity, or general relativity as it is normally abbreviated, was designed to replace Newton's 17th century theory of gravitation. In cosmology, gravitation is the dominating force overwhelming all others because of the vast mass of the cosmos. So, it is the gravitational theory that cosmologists turn to understand the expanding universe. Einstein's brilliance was to spot that although gravitation manifests itself as a force, it may also be understood in a completely different way in terms of warped geometry. Let me explain what this means. The rules of geometry we learn at school date from the time of ancient Greece. The subject is often referred to as Euclidean geometry after Euclid, who wrote it all down. There are many well-known theories that can be proved from Euclid's axioms. For example, the famous one named after Pythagoras. Another well-known theorem is that the angles of any triangle add up to two right angles, 180 degree. These properties of lines, circles, triangles, and so on are watertight, but they come with one important provision. They apply to flat surfaces. The theorems work correctly on blackboards and sheets of paper on school desktops, but they do not work on curved or warped surfaces such as globes. Pilots and navigators are well aware of this, and they have to use the different geometrical rules to cope with the Earth's curvature. For example, on the Earth's surface, a triangle can contain three right angles. If two-dimensional surfaces can be either flat Euclidean geometry or warped non-Euclidean geometry, could three-dimensional space also have either flat Euclidean geometry or warped geometry? Before Einstein, almost everyone assumed that space had flat or Euclidean geometry, straightforwardly extended from the rules we learn for two dimensions, but there is no logical reason why that may be so. Some 19th century mathematicians toyed with the idea that the geometry of three-dimensional space could be a generalization of curved surface geometry. They worked out the geometrical rules for this warped space, but at the time it was treated simply as a mathematical game. All that changed with general relativity. Einstein proposed that a gravitational field can warp three-dimensional space, necessitating the use of non-Euclidean geometry to describe it. What then is curved space? One way to imagine it is to think of a triangle drawn around the sun. Importantly, this must be a flat triangle, that is, it lies in a plane. Now measure the angles and add them up. If Euclid's geometry applies to this situation, the result will be 180 degree. Einstein, however, claimed the answer should be slightly greater than 180, even though the triangle is flat, because the sun's gravitational field warps the three-dimensional geometry of the space around it. This experiment can actually be done more or less by bouncing radar waves off Venus and Mercury and doing triangulation. It turns out that Einstein is right. Space really is curved rather than flat. There is an important terminological nicety here. Where cosmologists talk about flat space, they don't mean space flattened to a pancake, they mean three-dimensional space with Euclidean geometry. Sometimes the curved geometry near the sun is described by saying that sun's gravity bends light rays passing near it, in which case the triangle would have distorted angles because the sides are wonky. This is true. It is an equivalent way to think about curved space, with the important point that the wonky sides are actually the straightest possible lines that can be drawn in the warped geometry. So it isn't just a matter of straightening the bent light beams out and recovering Euclid's results. The space is irreducibly curved, and no amount of manipulation will make it conform to Euclidean rules. The warping of space round the sun, although detectable, is nevertheless tiny. Its existence was confirmed by the English astronomer Arthur Eddington, who measured the bending of light by observing the slight displacements in the position of stars in the same part of the sky as the sun during the 1919 total eclipse. Eddington's star beams were bent by the amount that general relativity predicted, and this dynamic confirmation elevated Einstein to celebrity status. The space warp is small because the sun's gravitational field is weak by astronomical standards. Today, we know of what other objects in space with much larger gravitational field that bends light more noticeably. One striking example occurs when a galaxy interposes itself between Earth and a more distant light source. Under these conditions, the galaxy bends the light around it on all sides, rather like a lens, causing the image of a distant source to be smeared out in an arc. In some cases, the image forms a complete ring, known appropriately enough as Einstein ring. The most extreme bending of light or warping of space occurs round a black hole. In this case, the space warp is so strong that it actually traps light completely, preventing it from escaping. I have simplified the foregoing account in one important respect. In this earlier so-called special theory of relativity, published in 1905, Einstein demonstrated that space is linked to time in a manner that makes it natural to consider the whole package, space-time, together. Space has three dimensions and time has one, making four dimensions in all. Hermann Minkowski, one of Einstein's mathematics teachers, worked out how to modify the rules of Euclidean geometry to describe four-dimensional space-time. Daniel Dennett, from Darwin's Dangerous Idea. Did you ever hear of universal acid? This fantasy used to amuse me and some of my schoolboy friends. I have no idea whether we invented or inherited it, along with Spanish fly and saltpeter as a part of underground youth culture. Universal acid is a liquid so corrosive that it will eat through anything. The problem is, what do you keep it